Here's problem 35C from the STAX chemistry textbook. And here we don't have initial or finals or a change, so we're going to use the ideal gas law. As I've been mentioning in many of my other videos, you really want to pay attention to the units of R. Think of it as a guide, because these units kind of tell you what the pressure and the temperature and the volume need to be in for things to work correctly. Okay, so let's first just start going through some things first before we solve for something. All right, so we have a volume of 221 milliliters, and we know that that must be in liters. So divide this number by 1,000. Just put it next to this. This is 0.221 liters. Okay. Next, look at the pressure. The pressure is 0.23 torr. Okay, maybe you've already memorized that torr and millimeters of mercury are the same thing. But here, this is not atmospheres. Okay, we need atmospheres because R has units of atmospheres. So 1 atmosphere is 760 millimeters of mercury. And the units here cancel, which is great. And we're left with atmospheres here as the pressure. So let's grab our calculator. And my calculator gives this to me in scientific notation because it's a rather small number. So 3.0 times 10 to the minus 4 atmospheres. And I'm trying to retain those two significant figures there. Okay. Temperature. We all know that that's always supposed to be in degrees. I'm sorry, the degrees Celsius doesn't work. So we need to add 273 to any Celsius temperatures we have. And if we do that, we get 219 Kelvin. All right, Kelvin and Kelvin. Okay, so that matches. And we don't know what moles is. Now, in this word problem, they're asking us for grams, okay? Grams, how many grams? And we do know that the chemical substance is argon. So what we're going to have to do is solve for N, find N, and then at the end, we're going to convert to grams of argon using the identity of the chemical substance and our periodic table. So we have PV is equal to nRT, and we want to solve for N here by dividing both sides by R and dividing both sides by T. And so we get a new formula. N is equal to P, pressure times volume, divided by the ideal gas law constant, divided by temperature. Okay, so we can plug and chug here. Make sure you use your converted values in all of the math here. Okay, so use the atmospheres for the pressure. Use the liters for the volume and the ideal gas law constant. Is that whole business, right? And the temperature is 219. All right, it's always a good idea to make sure that your units are canceling. You can see how I actually forgot to write ATM here. I'll squeeze that in. So atmospheres and atmospheres cancels, liters and liters cancel, kelvins and kelvins cancel, and we're left with moles. So that's what we want. So N, which is what this all equals. Let's grab our calculator. And I'm going to do this a couple times just to double check my own work to make sure that I'm getting the same answer twice. It's always a good idea. So the moles here is I'm going to round this off to 2 sig figs, 3.7 times 10 to the minus 6. Okay. And let me double check that. And hopefully we get the same answer twice. Okay, so I double check that. Now, what we need to do is convert from moles to grams. And so we look on the periodic table and we find argon. Argon is in the noble gases. It's element 36. I'm sorry, element 18. And so 1 mole of argon is 39.948. Okay, so what does that number mean? It means this many grams is equal to 1 mole of the substance. Okay, and so we're going to now convert this amount using this equivalency. So we use the conversion factors. Let me see if I can squeeze it in here. 3.7, 10 to the minus 6th moles of argon. Okay, and we'll set up our conversion factor here. We know that 1 mole must go on the bottom so that the moles cancel, right? And up on top, we put the number we find on the periodic table. Okay, and let's grab our calculator. 3.7, 10 to the minus 6, multiply by 39.948, and I get a value of 1.5 times 10 to the minus 4. Okay, and the units are grams, and the chemical is argon, so we normally write the chemical formula after the mass, okay? So that's how you do this problem. It's a great utility of the ideal gas law. Thanks for watching. Have a great day, and please consider subscribing to my channel.